dimensions of layers in convolutional neural network, I wanted to make it clear or explain to you more. So if we have an input image, let's suppose we have a 64 by 64 size image, 64 pixels by 64 pixels. It is a grid. It is considered as an input. And here we are using a kernel of size 7 cross 7, and it will be sliding onto your network. And a total of 6 such kernels are used. So one 7 cross 7, another one 7 cross 7, another one, all are different. And we have 6 such kernels, and each of them will have a bias value. Total we have 6 bias value per kernel, 1 per kernel. So the convolutional layer, the size would be now from 64, it will become 58 cross 58, and we will have 6 such output at the convolutional layer. So we applied this kernel, and the size was, we will have 6 outputs, each of size 58 cross 58. And then we have the subsampling or the pooling. So we will have 6 bias because we have 6 different inputs, feature maps from here, and the size will be reduced to half, so 58 by 2. So the size is reduced by half, but the number remains the same when you're doing the subsampling. And the convolutional size, now that we have here with the convolutional layer, this I wanted to make clear. So the size is the width, then the height, the input, number of channels in the input, and number of channels in the output. So it is mentioned over here. 6 is the input channels, 6 from here. Then we have a kernel of size 8 cross 8, and we are now increasing the number of channels from 6 to 16. This is what I mentioned in the previous lecture, but I think it was not clear. So we can increase the size, the channels from 6 to 16, or reduce them. So now what we will do, we will see clearly that the bias are now 16. So we have 16 different outputs like this, and then we have 16. And since we are going to do the max pooling, so the size will be reduced from 22 to 11. So after subsampling, we have a size of 16 and 11 cross 11. This will be the output after subsampling. 16 such outputs or feature maps, each of size this, 11 cross 11. And then the input, since this is your input, 16 feature maps, and the output is 15 fully connected nodes. So the output is 15, and size of each feature map is 11 cross 11. So before that, we will have a flattening layer, or we could use the global average pooling layer. So this is the dimensions of your layers: the input channels and the output channels. So these output next will become the input for the next layer, right? We can see here that this was the output, it became the input, but we now want to increase the number of channels after the convolutional layer. So we will have 16, and each of size 22 cross 22. because we have a size kernel 8 cross 8. And the input for this next layer will be 11, and the output is again 16. So for this will be given as an input at this layer, and the output is 15 since we want 15 outputs. So this defines the input, this defines the output, and this defines the middle part, it defines the kernel size. So this is the explanation about the dimensions of your different layers in CNN. So the max pooling or the pooling layer, it divides the size by half. That's the general rule. And also when we apply the convolution kernels, it also reduces the dimensions. For example, after the convolution from 64 we are left with 58, and again from 22, from 29 we are reduced to 22. So it also reduces, so we can apply the concept of padding if it is same and you are using some libraries in TensorFlow or Keras. So if we keep it same, for example, the size of the image is 6 cross 6 cross 1, that means only one channel, and we have a kernel size this. So we add the padding so that if we have an image, so if we have an image of size 5 cross 5 and we pad that to become 6 cross 6 image, padding means you add, for example, this was your original image, then you add additional pixels as the padding, and then you apply a kernel of 3 cross 3 cross 1. The convolutional size then will become the same as the input image. So we have to understand the concept of convolutional kernels and using padding such that the input and the output have a correspondence. So I already told you that we can increase the size after the convolution by determining the number of output channels. We can change the channels. Now in this case, when you will be doing your algorithms, most probably you will be using this concept so that the convolution matrix or the convolution outputs has the same size as the input image, and we choose a kernel of size 3 cross 3 cross 1. So I recommend when you're using your implementation using TensorFlow, use the padding in your convolutional networks, as the option is choose as the same. But however, if we do not add the padding and the output kernel matrix size will be 3 cross 3 cross 1, and we call that is valid padding. Okay, so this is a GIF I got by Creative Commons, and you can see the convolution operation with the 3x3 kernel that is applied on this image, and it is a stride of 1. So it starts here, then 1 pixel, then 1 pixel, it is moving, and then 1 pixel down. So we have a stride of 1, and this will be your convolved features. Then we have the concept of pooling. So we introduced two concepts, max pooling and your average pooling. So in the max pooling, what you do is you find the maximum value among all the pixels and assign that value. Whereas in case of average pooling, you're going to take the average of all the pixel values and then place it here. So it is placed here by taking the average. And this shows the concept of pooling. You could have a larger size of your pooling as well, which is taking more pixels, and then reduce the dimensions drastically. So this is an example of pooling, and then differentiation, or the difference between max and average pooling. So this is a small recap of convolutional neural networks, and I explained the dimensions of your convolutional outputs or your feature maps, how they are determined, and the dimension of max pooling or your pooling reduced by half. And then I also mentioned that you can actually increase or decrease the number of channels in subsequent layers, convolution layers in this example. So if you have any questions regarding this concept, these concepts that I have revised today, or you have any queries, you can email me at this email address. And I will get back to you with vigilance. Thank you.